So we're moving into section 6.3, exponential functions. So again, this is a function we haven't really dealt with. The graph of an exponential function is given. We want to select the function for each graph from the given options. So again, this is just working out an example. If you want to see a lot more about exponential functions, you should probably watch the videos based on the lesson itself. So I'm just going to go ahead and just kind of work this problem out. So again, we have the graphing calculator. We can type in y equals, I can type in just the parent function, which is just the 5 is the base to the x power. And if I hit the table, notice that 0 goes in. So again, if I have this y equals 5 to the x, notice how if I look at the table, if I put 1 in, notice that 5 to the power of 1 is just simply 5. If you put a 0 in, 5 to the 0 power, anything to the 0 power is 1. So 0, 1 is going to be an important point. So it doesn't really matter what the base is here. This 0, 1 is going to appear in the parent function without any transformations. If I put a -1 in, 5 to -1 is going to be like 1/5. Now, 1/5, if you look at my calculator, that's also the same thing as 0.2. So that's what it is a decimal. So if you look at behavior, as x gets larger, as x goes towards infinity, notice that the behavior of the graph, already when x is 6, it's at 15,625. So from a graphing perspective, I have this 0, 1 is here. That's a key point. 1, 5, it's already here somewhere. But notice that the graph really just shoots up really, really quickly. It's extremely steep. But notice that as you go across this way here, if you look at the negative side of it, notice that the y values rather quickly. Notice how we have this scientific notation, which means a bunch of zeros, like 4, you'd have to add 3 more zeros to this 3. It'd be like 0.00032. So we kind of pick up on just by looking at the x value being -4, and also that the y value is really close to 0. So what happens is the x-axis becomes a asymptote. So there's this horizontal asymptote here. Put that in a different color there. So that's kind of what our parent function looks like. So if I look at y equals 5 to the x, if I look at the graph of this, notice that, again, I probably need to change my window again. If I hit zoom and number 6, gives me, notice how it kind of takes on this real sharp turn along the x-axis to the left. It's just basically approaching 0. And notice that if you go to the right, the graph is really, really steep. And notice that there's about the only point we really can see is this 0, 1. So if I look at y equals 5 to the x, I'm looking for a graph that kind of looks like that. That's the parent function. So what I'm seeing is this graph right here looks like that one. So that's going to be my y equals 5 to the x graph. So if I look at these, so I'm using this as kind of where I want to start at, is this is my parent function. Now this one looks like there's a lot going on. The ones I have a really easy time with is the ones with just movement to the left or to the right. Notice how this -1 is up in the exponent. That's going to be an inside move. So remember, if it's inside, this is going to be backwards. So this means the graph should move to the right 1. So I'm looking really for this graph here, where there's that 0.01 to shift to the right 1. That's all I'm really looking for. The graph should still have the same shape here. So this one's opening the wrong way. This one, notice that the x-axis is down here. And this looks like it moved to the right 1. So I'm liking this graph. This one doesn't look like it's opening the correct way, not the correct way. This one looks like it went down. Notice how there's the x-axis, and this asymptote actually went down 1 here. So what I'm seeing is this graph here is this one here, y equals 5 to the x -1. I can also just type that in the calculator and get the graph on the calculator. You kind of match them up that way. So that one is kind of easy to do. The other one I'm kind of seeing easy to do is this 5 to the x minus 1. That means since this is on the outside, this means the graph went down 1. So the graph that went down 1, we already kind of noticed that was this one down here. Notice how the graph is still the same graph, but notice how instead of being at 0, 1, it's now at 0, 0. But the key thing is noticing that it's now approaching y equals negative 1. So that means it shifted down 1. So y equals 5 to the x minus 1 would be this graph. So I've got 3 of them done. So from here, ones I think I find easier to do now is probably this one. Notice I have y equals negative 5 to the x. Notice how this negative's on the outside. If the negative's on the outside, that's going to be a vertical reflection. In other words, this graph should reflect over the x-axis. So this should be over the x-axis. So what happens is the parent function, instead of pointing up, it's now going to be pointing down. And instead of running across the top, it's going to be kind of running down on the bottom here. So I'm looking for something that just basically makes this one flip upside down. And it looks like this one right here is doing exactly that. Notice how the asymptote is still y equals 0. So notice how it's still approaching the x-axis from the left, but notice how instead of this part opening up, it's now going to be opening down. That's going to be that y equals negative to the 5x, negative 5 to the x. So if I do want to double check myself there, y equals, I type in negative 5 to the x, it should make the graph reflect over the x-axis. So we got that one out of the way. The next easiest one I see is probably this one. This is on the inside, so this is going to be over the y-axis. So that means this graph is going to flip. If I look at the parent function, this part that was opening up over here is now going to be opening up over on the left side of the y-axis. Since now, instead of approaching 0 from the left, it's now going to be approaching 0 going towards the right. So this graph should be kind of running in this direction here. The one I'm seeing doing that is this one right here. That looks like the one we want is this y equals 5 to the negative x. So again, if I want to double check myself, y equals, clear that, 5 to the negative x. If I graph that, notice how it does match that. So now we're down to, we got 7 more to do. So we've done that one already. We just did that one over the y-axis. The next one I think would be easy to do. Notice how there's this negative 5x. That's going to be basically this graph here. Notice how there's this 1 on the outside. That means it's going to be moved up 1. So this is going to be this graph moved up 1. So remember, this graph was this graph here. So we're going to be looking at this graph here. But this graph here should be moved vertically up 1. So we should have like a y equals 1 thing. So notice how this one over here, notice how it looks like the same graph, but now it's moved up vertically 1. So I have this is going to be then, this is going to be the y equals 1 minus the 5 to the x. So that's going to be a vertical shift up 1 from here. So we've got that one done. So the next one we're kind of looking at is, notice how this has got a negative x and there's just 1 here. So it looks like this is all inside. So this means this graph should kind of look like with the y equals the negative 5x one, or the negative x and the x one, which would be this one here. So this graph here was here. So I should be looking for this graph here. But what I need to see though is some type of movement on the inside. So I'm looking for this graph here, but moved. So if I look at this graph here, notice how it has been moved. It's been actually moved to the right. Okay. So that's going to be this graph here, y equals 5 to the 1 minus x. So if I double check myself there, y equals 5 to the 1 minus x, if I graph that, notice how it does kind of slide to the right. So the catch with that one is really you should have like y equals, there should be like this negative on the outside. It should be like that. When I factor that negative out, this should become like a positive x minus 1. So that's how there really was this x minus 1 inside here. This x minus 1 really means to move to the right. And also have this negatives on the inside as well. And that would be a reflection over the y-axis. So the graph would have to do these two things, slide to the right and reflect. Okay, so we have that kind of going on there. So we got that one out of the way. So now we have like y equals -5 to the negative x. So this one should have two reflections. It should be opening down, but then it should also be reflected. So I need to really be putting these two graphs together. This graph here and this graph here together. So if I start with this graph here, it's going to look like this, but then it's going to reflect and go in this direction here. So that's kind of what I'm looking for, is a double reflection. So do we see a graph that's kind of doing that? Looks like this right here is doing that. So that's going to be the y equals this -5 to the negative x. So I kind of see this graph, but then since there's a negative there, that's going to make it reflect over the y-axis as well. So we kind of got that going on. So it's got two reflections. It's got over the x-axis and over the y-axis. So again, if I wanted to double check myself, I could do a -5 to the negative x. Let's see here, y equals, that looks correct. And that's how it does match that graph there. So now we're down to this one out of the way. So now we're left with, looks like we got them. Oh, we already did the 1 minus x. That one was this one over here. So we've already done that one. And we just did that one. So that completes the graphs there. So notice how we can apply the transformations and not have to really put these in the calculator if you don't want to, but you can put them in the calculator to verify.